Hey, this is Mr. Warden, and this is a video key for Do Now 21.3. That's week 21, day 3. So here's our first question. After 9 years of collecting Swiss cheese holes, you had 403 holes. After 13 years, you had 515 holes. Is there any rate in this scenario? Okay, so our options are yes, but you would have to work to calculate it. Yes, the rate is handed to you. It's 13 over 9 holes. Well, 13 over 9 doesn't actually relate to holes. It relates to years, 13 years and 9 years. It's not really a rate at all. So really, you're going to have to calculate it. We could find a rate in this situation from 403 holes to 515 holes over from 9 years to 13 years, which would end up being a slope. But you'd have to work to calculate it, and you'll probably need to for this situation. But we'll come back to that. Are there any sets of related data, like X, Y points? Well, in fact, there are. So let's consider that. So let's think about this. So yes, you could identify a point at 913. Well, that means 9 years and 13 years. Well, they aren't happening at the same time, so that doesn't really make a lot of sense in this scenario. So that's a no. Yes, we could identify a point from the related data of 9 years and 403 Swiss cheese holes, and another at 13 years, 515 Swiss cheese holes. And that makes more sense because 9 years and 13 years, those are our times, those are our inputs, and the outputs are 403 Swiss cheese holes and 515 Swiss cheese holes. Why you are collecting Swiss cheese holes, I cannot explain that. I can't explain your choices, but apparently you are. So the answer is yes, we can identify a point from the related set of data here, and we can find another one. Okay, so if you thought 9403 and 13515 worked as points, you were absolutely correct. Now I'm going to zoom in a little bit here so we can see this chart more clearly. Okay, so let's see which equation type makes the most sense. Is there anything like a rate in the story? I'm going to say no, definitely going this way. So there is, I'm going to go ahead and draw our path. Okay, so we're going to go this way. So no, there is nothing like a rate directly in the story. You'd have to work for it. Do you have any sets of related data? Why, yes, we do have that. Okay, do we have 2 points? Yes, we do. Are they both intercepts? Well, to be an intercept, one of the values in a point has to be 0. So an x-intercept would be 0, comma, some value on the y-axis. And a y-intercept would be, that's a y-intercept would be 0, comma, some value on the y-axis. An x-intercept would be some value on the x-axis, comma, 0. So no, we do not, because we have 403 and 13 515. So we're going to go the no path. Okay, is there a way to find the slope? Oh yeah, there's definitely a way to find the slope. Use them to find the slope. We can do that. And then we'll end up over here at the point slope form. So point slope form for the win. Okay, if you recall, the point slope form is y minus a known y value that we're working with equals slope times x minus the related x value for that y value. So we will either be using the point 9,403 as a point for this, or we could use 13,515. So 515. Okay, we can use either one of these points. Now we're going to need both of these points to get the slope, of course, and we're going to have to get the slope. So if you chose point slope form, I would tend to agree with you. You have 2 points and you can calculate the slope from them. So try to create a point slope form equation. Let's work that out. So we have these points. So to get slope, we take the two y values and we get their difference. So 515 minus 4. Come on, mouse pad, you can do this. 403. That is the change in y, and the denominator has to be changed in x. Since I started with 515, I had to start with 13. So 13 minus 9. And when I work all that out, I end up with 112 over 4. And 112 over 4 comes out to 28. So the slope is 28. So I can make a point slope equation. So I'm going to write it like this. Y minus y1 equals slope times x minus x1. And then I'm just going to replace slope with 28. I'm going to replace the x1. Well, I'll go with the 9. We'll go with that point. 9. And for y1, we will go with 403. And of course, I could also use 13 for x and 515. Both of those are completely legit equations. All right, so if you came up with a slope of 28 and an equation of either y minus 403 equals 28 times x minus 9, or y minus 515 equals 28 times x minus 13, you're in good shape. So that works quite well. So if we could assume you've been collecting Swiss cheese holes at a steady rate, how many Swiss cheese holes did you have after 3 years? All right, so how do we do that? So time, numbers of years is represented by x, and the number of Swiss cheese holes is represented by y. So we take either one of our equations, we're just going to replace x with 3. And so now we can just start solving that. That's y minus 403 equals 28 times, well, 3 minus 9 is negative 6. So we got to work out what 28 times negative 6 is. I'm going to go ahead and do this. 28 times negative 6. And I end up with negative 168. Okay, so I end up with y minus 403 equals negative 168. And now I need to add 403 to both sides to find out what y will be. So negative 168 plus 403. And let's work out what that is. When you've got a situation like this, you can say 403 minus 168. You can do it in that order, or you can do it in the other order. So you end up with 235. Okay, so it's 235 Swiss cheese holes. So there would have been 235. And the reason I say you could do it in either order is addition can be reversed, and this is addition. So this could become 403 plus negative 168, which is 403 minus 168. So we will have a point at 3, comma, 235. And that will tell you, that tells you that after 3 years, you would have collected 235 Swiss cheese holes according to this model. All right, I hope that has been helpful. I will show you how you could have done that, work that out on Desmos. So here I've got a Desmos graph. I've graphed the equation, and I created another one that's x equals 3. And if I move the graph down until I find where x equals 3, which is this vertical line, intersects with my equation model for this scenario, I find where it is, and I click close. There it is. This is the point 3, 235. So 3 years, 235 Swiss cheese holes. I can do other things like figure out how many years it takes me to get 800 Swiss cheese holes. and I click on that y equals 800. So I am saying, when y is 800, I'm going to see where y equals 800 intersects with my model. And there it is, 23.179 years, and 27.179 years will be a little more than 23 years. So it'll take a little more than 23 years of collecting to get to 800 Swiss cheese holes at your current rate. So you might want to up your game if you really want to get there before too long. All right, well, good luck collecting Swiss cheese holes, and I hope this was helpful.